Hey y'all, Data Guy here. And today I have a video for you where I want to go over and show you how you can export data from a Amazon DynamoDB into an S3 bucket. The context of this will be, let's say, you want to back up data from your AWS DynamoDB to an S3 bucket, but this can be used in many different ways. A lot of times you'll just have your data kind of sitting in a DynamoDB as needed, and you can't necessarily bring that data straight from DynamoDB into a SQL database. You need to drop it into a staging S3 bucket before you upload it into wherever, whatever backend storage you're using. So that's exactly what we're going to get into today. So I'm going to show you how to set up a My DynamoDB table, just kind of show you how to interact with it through Airflow, back up its data through an S3 bucket, and then clean up those resources after you're done. And the only package requirement you'll need to have is your Apache Airflow provider's Amazon. And then we can just create a new DAG in my local Airflow environment. Check out previous videos if you don't know how to create an local Airflow environment. But here we're just going to create a new DAG called Dynamo 02 S3.py. And then to get started on this DAG, what we will do, as with every Airflow DAG or Python script, is import a whole list of packages and requirements. So first thing we're going to import is annotation, so we can annotate our code, logging, so we can interact with and propagate messages to the logging interface, date time, so we can use date time objects, boot23. This is a really critical one. This one is how you're actually going to be interacting with your S3 buckets. It's essentially kind of a Pythonic way to interact with AWS resources. That actually reminds me, you're going to need to have boot23 in here as well as your requirements within your file to actually import it, and also tenacity for this particular DAG as well. So misspoke earlier, you're going to need to actually have 3 requirements within there. And then tenacity is basically just an interface that is going to allow us to kind of set conditions based on a log state. So before a log occurs, before a sleep log, tenacity just allows us to parse those messages and use them as triggers. Then Airflow decorators, we have our task decorator to create tasks in Taskflow API, chain operator, which will just allow us to chain tasks together, DAG model, you know what that is. And then we have the S3 create bucket, S3 delete bucket operators, and the DynamoDB to S3 operator. And then we're also going to import the trigger rule, so we can set more complex trigger states based on upstream dependencies, and also this system utility for testing and building a context ID for interacting with Amazon. This is the part that can be subbed out if you want to just use a regular AWS connection. Every point where you see this system context builder being used as the authentication method, you can take that out and just put in a normal AWS connection, use it there. But this is just how AWS likes to present their resources. So first thing we're going to do is set a logger. So just set logging, initializing a instance of get logger so we can interact with logs. Then we are going to set a DAG ID. So example, DynamoDB to S3, and build our system context builder. So this is just going to build that kind of system environment that allows us to interact with AWS without needing to explicitly set the connection at every level. And then we're going to set some table attributes for our data. So here we're going to have some table attributes of ID, attribute type S just means string within DynamoDB, and also value. And then we're also going to create a table key schema where we're going to say, hey, each key types or our attributes are ID and value again, but setting their key type as hash and as range. Then we will also set our table throughput and our S3 key prefix. So this is kind of the base, the root name of our S3 buckets. Then we also are just setting the table throughput capacity for DynamoDB. So allowing it to read in one table and also write out one table at the same time. Next, what we're going to do is use tenacity to enable point-in-time recovery. So here, we're really just using tenacity to, again, implement that kind of more complex retry logic. So here, we're going to declare this using the task API at tenacity retry. So using the retry method of tenacity and initializing this as a Python task or a Python task API task. This is going to implement retry logic to enable point-in-time recovery for that DynamoDB table. So essentially what's happening here is we're going to say enable continuous backups and basically ping this database, back it up to restore data at any point within the past 35 days. And it also might need multiple attempts. So the reason why we have multiple attempts here is you might get timed out when it tries to actually trigger that update continuous backups. So we have that retry motion here. So stop after 20 attempts, because that means it actually really shouldn't, but also keep trying it up until that 20, because we do want to enable point-in-time recovery here. Then our next task is going to be a task that's just going to create a DynamoDB table with a predefined schema and enable that point in time recovery. So calling that tenacity task we just created. So here, setup table, reading in table name as a string. And then what we're going to do here is just simple Python script that is going to set up Dynamo resource as a Boot23 resource. And then we're going to create a table within that Dynamo resource. So using Boot23 with the table attributes we set earlier, table name, table key schema, table throughput. So all these attributes that we set previously, just setting them here to create our Dynamo resources. So we're creating our Dynamo table. And then also getting a waiter to just wait and check, hey, does the table exist? So this function is just checking that table we just created, actually was started. And then we're also going to enable point in time recovery. So that's why we have this wait function to make sure the table was actually created before we try to enable point in time recovery on it. So we don't trigger that action when there isn't a table for it to actually be enabled on yet. Then we're just going to put a very simple item here. So table put item with the ID 123 and the value of testing. So just some dummy data to insert into our table for the use case of this DAG. Then our next task is going to be getting export time. So here, all we're doing is just retrieving the earliest point in time to which the DynamoDB can restore. So just describing the continuous backup policy we set up here. This is just making sure that it exists, and it'll tell us what the furthest back we can restore our DynamoDB table from is. Then we're also going to define a function to wait for a bucket. So here, similarly to what we did up here where waiter table exists, we're just making sure that this bucket exists before we trigger any downstream actions off of this. So it's just a simple waiting function to make sure that our S3 bucket has been created before we try to interact with it. The next step is delete DynamoDB table. So we're going to call it the end of our DAG to delete the table and just kind of clean up our environment. So similar function, delete, and then also using the waiter to check that the table does not exist anymore with some more delay and max attempts. So now we've got all of our tasks mostly lined up. What we can then do is just define our DAG. So here we're going to define our DAG using our DAG ID, pretty bog standard arguments, won't talk about anything there. And we are also going to set up our system context. So here, this is where you're importing your environment ID key that you're using to authenticate to AWS, or you're deleting this whole section and you're just using an AWS connection in the task definitions yourselves. Here we're building our table and bucket name using that environment ID. So using the environment ID that we set. Again, you're going to want to set this via an environment variable, just that's a unique key to identify the environment you're using to interact with AWS. Otherwise, you can pull this out from really wherever you want. Then we're also going to create a table. So you set up table name equals table name. Again, we set that up earlier. Then we're also going to create bucket with the name bucket name. So here, bucket name equals bucket name. S3 create bucket operator. And then we're going to use the DynamoDB to S3 operator to back up our database. So here, backup DB equals DynamoDB to S3 operator, task ID, then just passing it our table name, bucket name, and our max file size in bytes. So you're definitely going to want to have this at more than 20 bytes. That's a pretty puny table. But in this case, we're literally passing one data file, or one data point. So you can leave the file size as 20 bytes. Then I kind of want to show you just a couple options for how you could back up alternatively. So let's say that we want to do a segmented backup, or we want to segment the backup process into two parallel tasks, and potentially improve performance for larger tables. And so here, similar table name, bucket name, but then we're also adding this S3 key prefix to save them in different locations. And then we have our scan KR, so total segments, and this will, as the DynamoDB is scanned and export S3, it's going to do it in two halves, basically. Next, what we have to do is a second kind of type of backup, backup segment 2. So here, this is just because this one's segment 0, this is only going to upload half of it. Then we need a second one that's going to upload the second segment into our S3 bucket. And that's why we have 3 key prefix and add 1 and 2, because you'll need to have 2 separate locations that you're bringing it out to if you are using this kind of segmented export approach. Then we have export time equals get your export time. So here, backup database to a point in time. So here, just getting the export time of a table name. So all this is doing here is using this function we created earlier to get the latest point of backup that they can use. And then here, backup database point time, we are just backing up to our S3 bucket the export time of that previous database backup. So saving that kind of snapshot into an S3 bucket based on that particular point in time. And then we're going to do max attempts equals 90 because this could potentially take up a long time. And so you want to have multiple options just in case, so it doesn't just fail out. Then we're going to do some cleanups. We've done our backups. We've got everything back in S3 from our DynamoDB. We're then going to delete the table. And then we will delete our S3 bucket as well, clean up all of our resources so IT doesn't get mad, and then use the chain function to chain everything together. So here we have chain, all of our different setups. So test context, again, you can take that out, create bucket, create table, waiting for that bucket to be created. Then we have our different test buddy or backup operations. So standard backup, segmented based on a single point in time. And this export time is just part of that. And then deleting table and deleting bucket. So all you'll need to do now, just run get test run.dag. So what's our dag called? dag, and you're all set. So that is all you need to do to set up a export from your DynamoDB into an S3 bucket, whether it be for backups or any other type of purposes. Easy way to do it. And so I hope you found this video helpful. I hope you use it out in the wild. I hope you have a great rest of your day. Data Guy out.